In our previous lessons, we've been working on rational expressions, and we were talking about adding and subtracting them. And then we started moving into solving rational equations. Let's do a quick review of adding, subtracting some rational expressions and see how that can help us with our equations. So again, here's an expression, 3/4 plus 7/4. We know that when you're adding rationals, they should have the same denominator. Well, we have a common denominator here of 4, so we don't have to worry too much about it. So we can add our values. If I have 3/4 and 7/4, that means I have a total of 10/4. We also said, working with the rational expressions, we wanted them in their simplest forms. We're going to think about the factors that make up our numerator and denominator. 10 comes from 5 times 2, and 4 comes from 2 times 2. That means they have a common factor of 2 that we could divide out. That means we'd be left with 5/2. Here's another expression, 15/14 minus 3/7. Again, we said rational expressions should have a common denominator. Well, we know 14 comes from 7 times 2, and here we've got 7. I could have a common denominator of 14 if I just change this to have that happen. Well, how are we going to make a 14? We said 7 times 2. So if we take our second piece here and multiply the numerator and denominator by 2. Why do we want to multiply both of those by 2? This is a value of 1, so we're not changing the value for this part of the expression, just the form that it's written in. So now we have 15/14 minus 6/14. The denominators are the same, so we can finish out the subtraction. Well, 15 minus 6, that's 9, so we have 9/14. 9 and 14 do not have any common factors to divide out, so that would be our simplified expression. So common denominators are important when you're adding and subtracting your rational expressions. That should play into our rational equations. So again, let's take a look at our first example here. Here's our rational equation. Check the denominators. We need to have a common denominator in order to add, right? So let's see. We've got 3, 2, and 6. We don't have a common denominator. What would be the common denominator? Let's think about what we have to work with. 3, that's 3 times 1. 2, 2 times 1. 6 comes from 6 times 1 or 2 times 3. These are elements of this denominator, so we could have a common denominator of 6 in order to add the expressions together. So if we know what the common denominator is, how is that going to help us find and solve our equation? Find n and solve the equation. Well, think again, rationals, that just means you have things that are being divided, right? So when you're solving, you want to undo the equation to get the variable by itself. So we want to undo the division. So how do you undo division? You multiply. So we're going to take what the common denominator should be and multiply it by every piece in our equation. So remember, we're multiplying every piece in our equation. So we're going to take all those numerators times 6 and those denominators times 1. And we know 1 times something is not going to impact its value, so we're going to leave it as is. So let's see what's going to happen. As I'm looking at our new rational pieces, we're going to think about, well, do we have any common factors like before to divide out? Well, 6 contains a factor of 3, so I could divide out a common factor of 3 from my first piece. My second piece, 6, has a factor of 2, so I could divide out a 2 and end up with 3. And here, they've got a common factor of 6, I could divide that out, that'd be a 1. So by dividing out those common factors, what equation are we left with? 2 times 2n, that's 4n. 3 times 1 is 3, and we have our 2n minus 3. Here's just a linear equation that we can solve like we normally do. So from this point forward, we could subtract 2n from each side, which would give us 2n plus 3 equals negative 3. To get n by itself, we could add 3 to each side. That means 2n equals negative 6. To get n alone, we have to undo that multiplication by dividing, and so we know that n should equal negative 3. As we saw before with the other rational equations that we're working with, you need to check and make sure the solution, it works. is it balanced? Are both sides of the equal sign in the original equation equal? And is our denominator defined? Defined means it's a number other than 0. So let's do our check. We're going to take the value for n and substitute it back into the original equation. Following the order of operations, let's see what occurs. We've got negative 6/3 plus 1/2 to see if that equals negative 9/6. Well, negative 6/3 is really a negative 2, and negative 9/6 is really a negative 3/2. So is negative 2 plus 1/2 equal to negative 3/2? Again, thinking about our common denominators, we can make this into halves, which would be negative 4/2. If I add a positive 1/2 to that, I will get back my negative 3/2. So we've got a valid solution. N equals negative 3. It's balanced, and look, all the denominators are defined. Let's try another equation. So here we've got our rational equation. Again, first thing, check out the denominators, and let's find a common denominator. So we've got 4, 2, and 6. What would be our common denominator? Well, we know the elements for each of these, and there are some common factors, but not all. We know that 4 comes from 2 times 2. 2 is 2 and 1, and 6 we could use a 2 and 3. So we can see there's a common factor of 2 that each of them have, but this had a 3, this had another 2. So if we think 2 times 2 times 3, that would be 12. So 12 would be our common denominator. Well, think about it. If you're dividing by 12, how do you undo that? You would have to multiply by 12. So we're going to take each piece of our equation times 12. Again, multiplying the numerators, multiplying the denominators. At this point, again, we're looking to see what can we simplify, right? So we know that 12 has a factor of 4, so we could divide out of 4, so we'd have 3 times 5. 12 is a factor of 2, we could divide out the 2, so that would be 6 times 3y. 12 does have a factor of 6, so we could divide that out, which would be 2 times 7y. Well, what's that going to leave us with? 15 plus 18y equals 14y. Again, just a linear equation that we could solve. So I could subtract 18y from each side, then divide by negative 4. Y is going to be negative 15/4. Again, we should check our solution to make sure that it's balanced in the equation, and make sure that our denominators in the original equation are all defined. So you could do that one of two methods. You could write down the check by hand, you could use your calculator. We'll just go through your quick check, so substituting it into the original. Now look, all the denominators are defined, so we don't have to worry about that piece. We want to make sure that this side of the equation gives us the same answer as this side of the equation. So using your order of operations, we're just simplifying, then continue to find the value for each of our pieces. So still more simplifying, and then making sure you have the right value. So if this is 8ths, we could write this as 8ths, multiplying it by 2, so we'd have 10/8. 10/8 minus 45/8, that would give us negative 35/8. So we're good to go. Here's another rational equation. Again, we know that we need common denominators, so let's see what we've got. X minus 11, x minus 11, and 1. Well, our common denominator here should be x minus 11. So if we're dividing by x minus 11, that means we have to multiply by x minus 11 to undo. So let's multiply all the pieces of our equation by x minus 11. And at this point, we're looking to see what can we simplify from each piece of our rational equation. Well, we've got a common factor here of x minus 11 that would divide out, a common factor here of x minus 11 that would divide out, and 1 divided by 1 that would divide out. So let's see, we have 6x minus 3 equaling negative 1 times x minus 11. That would be a negative x plus 11. Again, here's just a linear equation that we need to solve. So we're going to combine some like terms, so I could add x to each side, then add 3 to each side, divide by 7 on each side, so x equals 2. Again, we have to verify that this is the correct solution, so we're going to go back to the original equation and substitute it in. We want to double check, one, not only is the equation balanced on each side, but also are the denominators defined. So the first thing, denominators, 2 minus 11, that would be a negative 9. Negative 9, it's a number other than 0. So far, so good. Let's do some more simplifying with those numerators and see what we're working with. Here we have negative 12 ninths minus a negative 3 ninths. Well, subtracting is like taking the opposite, right? So it's really adding 3 ninths. What's that going to give us? A negative 9 ninths. Well, 9 divided by 9, that's 1. So we have negative 1 equals negative 1. We're good to go. One more rational equation. Again, when we're adding our rationals, we need to have common denominators. Let's check their denominators here. C plus 7, Z plus 7, 1. What would be the common denominator we need to add our pieces together? Would have to be Z plus 7. Well, if you're dividing by Z plus 7, to undo that, you'd have to multiply by Z plus 7. So let's multiply each piece of our rational equation by Z plus 7. Again, we're looking to simplify, right? So we're undoing, dividing out common factors. The Z plus 7s will divide out here with a 1, so we'd be left with Z. Z plus 7s will divide out here, so we'd have a 1. And then we'd have Z plus 7 times 3, which would be 3Z plus 21. Again, we're left with a linear equation that we need to solve. So we could subtract Z from each side, subtract 21 from each side, divide by 2 on each side. So Z would be negative 10. Again, we have to check our solution. Is everything defined and is it balanced? So going back to our original. Let's double check. Is everything defined? So check the denominators. Negative 10 plus 7, that's a number other than 0. Other than 0, so far so good. And let's see how it simplifies for the next part. Is it balanced? Well, negative divided by a negative, that's a positive. So I have 10 thirds plus a negative 1/3. So think about it. 10 thirds taking away 1/3. How many thirds would you have? 10 minus 1, that's 9. 9 thirds. 9 divided by 3 is 3. So it's balanced, it's defined, we have the correct value for Z. Now it's your turn. Now it's your turn to do some practice. The jumbled answers for your day 9 is on the back of your worksheet. They're also posted here. Double check that everything was printed correctly with the jumbled answers. And the expectations are that you're using the methods that we've talked about in our videos in solving your problems. You are checking your solutions, whether you're writing them on your paper or you're using your calculator to verify. You have to make sure, are the answers you're getting for the variables making each piece of your equation defined, so you cannot have a denominator of 0, and is it balanced? The left side of the equation gives you back the same value as the right side of the equation.